The 3, 4, 5 right triangle, the only circle that fits in there perfectly, has an area of pi.
In this video, Howie, who, if you don't know him, he's like the nicest person on the internet, he was lamenting that he was sad that in some of his videos, when he explains some beautiful fact like this, some people will reply with, why do I need to know this? How is this relevant? How is this applicable to my life? And his video was beautiful in that he was responding that there is no need for an application of this. It is just a beautiful fact, just like a piece of art. So in this video, let me show you how myself, a research mathematician, reacts and interacts with a fact like that. And in fact, you'll see that as I think about this, I'm going to come up with other questions that are related to why I find this interesting. I'm going to leave those questions for you to think about and hopefully answer yourself, and then I'll make another video with answers to my own questions. My first immediate reaction to a mathematical fact like this is that I find it beautiful because I didn't expect this to be true at first. So I wouldn't expect, for example, that radius to be an integer to begin with. I would expect that radius to be some irrational number, like a square root of 2 or something, and not just an integer. Never mind to be exactly 1. And because it is exactly 1, the area is exactly pi. So it all fits very nicely, which makes this whole picture just beautiful. And because that fact was so beautiful, immediately comes to mind other triangles, other right triangles with integer lengths, and I want to know what is the area in this case. So for example, if you take the 5, 12, 13 triangle, what is the area of that circle? Is it still pi? Is it the case that r is even an integer? I don't know. Or much more generally, take any Pythagorean triple integers a, b, c such that a squared plus b squared equals c squared. Draw the right triangle, the side lengths ABC. Now draw the largest inscribed circle and look at the radius. Is that radius an integer? Can you come up with a formula for that radius? We know that radius is 1 for the triangle 3, 4, 5. Are there other Pythagorean triples that give me a radius of 1? Can that radius be any integer? So if I want a Pythagorean triple that has an inscribed circle with radius equal to 17, can I come up with such a triple? And one can come up with all sorts of similar problems and similar questions related to this problem or this fact, and it is exactly all these questions and all the stimulation, all the mathematical stimulation that happens when I look at a beautiful fact like that, that makes that fact mathematically beautiful in the first place.